Our goal is to find the sum of the following series. We have the summation of -1 to power n, pi to power n, divided by 3 to power 2n times 2n factorial. Let me rewrite my 2n. And n starts from 0, goes to infinity. Well, do I recognize this? Is it familiar to me? Recall that from Maclaurin series, the cosine function, cosine of x, can be written as the summation of -1 to power n, x to power 2n, divided by 2n factorial, n starts from 0, goes to infinity. So cosine function has power series representation using Maclaurin series. Well, do I recognize any pattern here? Do I see any similarity here? Well, so far I have -1 to power n on my numerator, which is the same as -1 to power n. I also see 2n factorial down here, 2n factorial. So if I can create x to power 2n for this series, then I'm basically done. Take a look. Our goal is to rewrite pi to power n divided by 3 to power 2n in the form of x to power 2n, as you can see here. So this is my goal. We're going to do algebra. By algebra, pi to power n divided by 3 to power 2n can be written as, well, what I'm going to do, I'm going to write pi as square root of pi. If I raise it to power 2, I get pi back. And then here I have exponent n divided by 3 to power 2n. So my pi to power n divided by 3 to power 2n can be written as square root of pi to power 2 raised to the n, which is square root of pi to power 2n divided by 3 to power 2n. But this guy can be written as square root of pi divided by 3 to power 2n. So I have my x to power 2n here in the Maclaurin series for cosine. So cosine of x, which is written as the summation of -2 power n, x to power 2n divided by 2n factorial, and start from 0 to infinity, now has cosine of pi over 3. The square root of pi over 3, right? So here, let me just use some arrows to show that for x, we are using square root of pi divided by 3. They have the same exponent. The bases must be the same. So this is your x, which is equal to the power series that you're given in this question. The summation of -1 to power n square root of pi divided by 3 to power 2n divided by 2n factorial, or in simplified version, is equal to the summation of -1 to power n pi to power n divided by 3 to power 2n factorial. To calculate cosine of square root of pi divided by 3, you can use a calculator as well to approximate this number. So our series -1 to power n, pi to the n, divided by 3 to 2n factorial converges to cosine of square root of pi divided by 3. This is one of the use of Taylor series, Maclaurin series that help us to find the sum of other types of series. So in this case, we had the summation of -1 to power n, pi to the n, divided by 3 to 2n factorial. From Maclaurin series, recall that the cosine of x is equal to the summation of -1 to power n, x to 2n divided by 2n factorial. So if you can recognize x, then you're done. You have -1 to power n, -1 to power n. On the denominator, you have 2n factorial, 2n factorial. So our job is very easy. We need to combine these two the way that you can see x to power 2n. But from algebra, pi to power n divided by 3 to power 2n can be written as square root of pi to power 2 raised to power n. The denominator stays the same. Your numerator becomes square root of pi to power 2n. So now you can combine these two, numerator and the denominator, which is square root of pi divided by 3 to power 2n. So your x is square root of pi divided by 3. Since cosine of x is equal to the summation of -1 to power n, x to power 2n divided by 2n factorial, wherever you see x, we're going to use square root of pi divided by 3. Again, on the exam, if the question says, what is this sum? Approximate this sum. You're going to use a calculator and approximate this number. To approximate. So our series is convergent to cosine of square root of pi divided by 3.